Hello, in this very short video I would like to show you how to bring back into life a lithium-ion battery which looks to be dead, or at least your charger says that it's dead. It is basically quite simple process. We need just power supply, DC power supply. I'm going to use a common ATX power supply which has 5 volts here on the red cable. But first of all, little bit more detailed analysis. We have 2 cells. One cell is absolutely okay. This is not the okay one. Okay. Let's try to measure this one. Here we could see that it has almost 4.2 volts and nominal. I'm not sure because there is written nothing. Even the capacity is not written here, unfortunately, but it's probably designed for 2 volts, I guess, from the measured value. But the second cell has only 1.68 volts. It's too low voltage to be switching on the automatic charger, because pre-testing says that this battery is dead. And now basically this battery had only 0.7 volts, but I tried to, because I just made this 5 volt brute force charger, and I tried it before the video, unfortunately, so I little bit charged. And it's very simple. You just put minus to minus and plus 5 volts. You'll be putting only temporarily, not very long time. You'll be getting such a kick on pulses, but be careful because the battery can be blasted when you put much energy. Basically, what is the theory inside? You are just enriching a lot of electrons inside, a lot of energy, and in pulses, and these pulses can recover the confused electrons back into anode and cathode. Basically, that's the principle. And once there is bottom voltage means the voltage where the charger, like microprocessor controlled charger, professional charger for lithium-ion batteries, can evaluate that the battery is still okay and can start the charging the battery. That's your victory, or half of your victory. The second half is that there is no very high resistance and battery can be used. But as you could see that after certain pulses we got 2.5 volts, but the voltage is dropping down because we just put a lot of energy to electrons. We really pushed the electrons by brute force to be organized, but they are going back to their original positions because this energy is very fragile, I would like to say. like, I don't know what is the better word to describe, but this energy is not stable. You need to put it onto charger, and charger will be still pushing exact amount of energy for a very long time, since there is stability inside, and once there is stability, the charger will stop the charging and battery will be stable and okay. But now we will be testing the battery. I'm going to take we will be testing the battery in original charger for lithium-ion batteries. I'm going to bring it. So welcome back, and now we have everything ready. Here is a professional charger with a little reduction, and it's a little bit, is it possible? Here is a little bit melted, the plastic material, but it has no power. That's strange to be melted. Okay, I don't know why it's melted here. Never mind, it's working. We will just do retesting what is the current voltage, because voltage is still dropping slowly down, as I mentioned in my previous stream, that there is still frustration of the electrons inside. They are trying to reach different, like, not dedicated cathode or anode, but the opposite one. So let's check. But this looks quite stable. It's still 2.2 volts, and I think that 1.7 volt is the lowest. I'm not sure. Somewhere it's written on internet, but it is just for me it's just pragmatic approach. So I will try to charge it, and if it is possible, just to be seen on camera, okay. And if it's possible, the charging, and you could see that now it's charging perfectly. And if we have chance to measure it, yes, we have chance to measure it, nice chance. And you could see that now it's 2.7 volts, 2.73, 74, 75. Yeah, I'm a little bit blocking you to see the values, but now I moved my finger and you could see the increasing voltage values. So, and we just let it be to be charged, fully charged. When it's fully charged, the red LED diode change on green diode. So that's the marking. I just maybe need to control the overheating of the inner parts of the charger, because it's also consuming a lot of current. And moreover, meanwhile, I have another issue. Here I have 3 AA cells. I'm going to check which one looks to be the best, or which two are going to be the best, because I need to select them and I need to solder 2 wires and replace cell buttons in one temperature sensor, or maybe basically 2 temperature sensors, which I'm using on my solar system, like informative sensors. But those are quite important, and it makes me peace of when every 2 days or 3 days the cell button battery must be changed. I don't know why they have so big consumption, but I'm going to change the button cell battery LR44. I think that it's LR44, LR44, LR44. Okay, this has only 1.3 volts. It's at the end of the life, obviously. This is good. This has 155. It's quite fresh. And it's very strange because both of them were used in the same device, but it's usually happen when there is no balance. And this has 1.4. Maybe I can use also this one. 1.4 is okay. So I will use these two, but this one is the winner. This will be installed to more important sensor, and this one will be installed. Basically, this is not a more important sensor, it wasn't correct, but what is correct about this sensor is that it's very hard to put inside because the sensor is already integrated into exchanger, and it won't be so easy to reinstall it. So I would like to use 100% good battery to have long time satisfactory working sensor. But I need to I need to find some cables, but this is out of the range of this video because I don't know where I have some cables. Here is one cable, yeah. Basically, but this is very, very thick. I would like to have a thinner cable. Thinner one would be nice. Okay, I need to look around if there are some cables. Okay, here we have some cables. Okay, but it is out of this topic because I need to search a lot of cables. Maybe go to the pit and find another cables in the pit. But you could see that charger is still working. We have the second one which was in top state, and when we recover this one we would have two well working lithium-ion batteries. So I took them from the waste bin, and now I would have two perfectly working batteries. So I hope that I motivated you how to rebalance or recover the batteries which are not working, and this is which looked to be already died, and that was the aim, the goal of this video. And I'm already working on this fantastic video where I have N20, GN20, FAO 8200, and here I have next two such gadgets. This one is really, yes, this one is absolutely new one, and these ones I bought for very convenient prices, only €140 per piece, but these are recovered from certain things. But never mind, I like I like reusing the electronics, okay, because that's the only way of sustainability, not that we just forward the electronic for cannibalization and how to say this, reusing in the way that we completely decompose everything, all materials, all chemicals, and just do from raw materials or almost like basic materials the new one. Yes, it is energetically very what I would like to say. It's not convenient basically. It creates a lot of CO2 because it is very exhausted from energetic point of view. You need a lot of energy to do that. So it's better when you have an idea, and if you need something like this one, somebody in China just cut off the wires and just is selling these salvaged motors for some hobby makers or hobby project makers like me, and for very convenient prices. Yes, and this is good. Okay, thank you very much for watching this video, and this was just a little bit my talk, my evening talk before going. Okay, thanks a lot and bye bye.